Since its start, aircraft engineering has undergone significant development from sophisticated aviation to stealthy and streamlined designs. Modern aircrafts possess incredible capabilities. Let's examine the distinctive activities of some of the world's most expensive military aircraft and highlight their efficacy and support missions in today's segment. Hello everyone, and welcome to another video. Today, we'll be looking at the reason why this $2 billion US stealth plane can't be bought. Yeah, you heard it right. So, let's start our video. The US Air Force runs some of the world's most modern and dependable aircraft. Designed by Northrop Grumman in the late 1980s under extreme secrecy, the B-2 Spirit stealth bomber is an engineering marvel that is operated solely by the United States Air Force, with the potential to deploy conventional and thermonuclear weapons, including 88 Mark 82J GPS-guided bombs and 16 B-83 nuclear bombs. The aircraft is a crucial component of the nation's long-range Stryker armament and one of the world's most survivable aircraft. Its early development in the 1970s sparked a great deal of controversy and criticism in the United States Congress due to its enormous operational expenses, which reached $737 million per aircraft, and total program expenditures which reached $2.13 billion per aircraft. In 1980, however, the government formally declared the commencement of the stealth aircraft program, which would allow the nation to construct manned and unmanned aircraft that existing air defense systems cannot intercept. Its low observability enables it to bypass even the most sophisticated defenses of its opponents. Embedded engines, sophisticated coatings, and a unique flying wing design all contribute to the B-2's low observability and advanced stealth characteristics. Before a B-2 can take to the sky, many requirements must be met. The ground crew is tasked with refilling the aircraft from a certain distance at a fixed flow rate. Once refueling is complete, the ground crew detaches the gasoline pipe from the aircraft and uses a towing vehicle to remove the refueling equipment from the apron. The 19,000 pounds of power provided by the 4 GEF 118 turbojets enable the 170-ton aircraft to take off successfully. The B-2's maintenance process is also essential to its successful operation in the air. This entails inspecting the aircraft's armament base, replacing the hydraulic fluid in the wheel well, and doing all other pre-flight checks. In addition, the maintenance staff does require a physical inspection of the engine intake. Due to the height of the aircraft, a ladder is required to reach the top of the aircraft. For the protection of the B-2 surface, the climbing team's footwear is covered with protective material. In addition to adequate and timely maintenance, the United States Air Force strives to create effective operational procedures to enhance the combat capabilities of this aircraft. Hot pit refueling is a technology that enables the refueling of an aircraft without shutting down its engines, hence ensuring a smooth operation. A fueling truck is positioned near the parked plane, and a supervisor connects the vehicle's hose to a hydrant. The refueling team then attaches the second fuel hose to the refueling port to ensure that the procedure is carried out safely. This strategy significantly reduced the number of man-hours necessary to complete the operational task. When this method is not possible, aerial refueling, also known as air-to-air refueling, is the most efficient alternative. This mid-air refueling technique involves the transfer of fuel between two aircraft. The tanker and the receiving aircraft begin by inching closer to one another while keeping a 100-foot separation. Using a Boom Type Pro, a probe on the receiver is plugged into the refueling tanker. The pilot of the receiving aircraft must open the refueling port, which in the case of a B-2 aircraft is a Type 1 rotation, in order for the tanker operator to connect the boom to the port. Several famous aircraft in the US Air Force are designed to do this mission with ease. The KC-135 Stratotanker is a notable example of such a refueling tanker. Depending on the fuel storage configuration, the tanker is equipped with a flexible refueling system and can carry up to 83,000 pounds of cargo in its cargo bay. Under its 35-degree spread wings are 4 CFM56 turbofan engines, each of which produces a thrust of 21,633 pounds. The KC-135's primary fuel transfer mechanism is the flying boom, which can transfer virtually all internal fuel. However, the distinctive aircraft features a shuttlecock-shaped drogue that may also be used to refuel some planes. In areas where neither mid-air nor ground refueling is possible, the US Air Force deploys movable fuel tanks or bladders capable of holding thousands of gallons of fuel in distant places. As gasoline containers, these flexible and collapsible flexi bags serve as fuel storage bladders. A cargo aircraft such as a C-17 Globemaster is available on demand for such an operation. As the gasoline trucks approach the rear of the aircraft, the fuel bladders are loaded onto the cargo deck. These gasoline trucks are used to fill the bladders with fuel through the fuel hose in a matter of minutes. Once loaded, the crew tightens the adjustable skirts and towing straps and secures them to the airplane's cargo area. In a mission requiring the C-17 to airdrop these fuel bladders, a strap net is employed to convert a standard storage tank into a flexible, transportable tank. Using an exterior ramp attached to the transport vehicle, they're loaded into the airplane's cargo compartment. This laboratory serves as the primary point of service control for all fuel-related support concerns. Fuels, propellants, chemicals, lubricants, gases, and cryogenics are just some of the areas in which it offers a comprehensive variety of scientific and professional services regarding any and all aerial vehicles, systems, and equipment that are maintained and operated by the United States Air Force. The laboratory is in charge of producing fuel product specifications as well as methods for ensuring the fuel's quality. In addition to keeping a quality check on the fuel elements, the fuel lab also goes through significant modifications to improve its efficiency and provide a faster turnaround time with its services. In order to make the fuel lab more environmentally friendly, some components like the fuel yard's filtration pumps, storage pumps, and gasoline storage tanks are improved or replaced. This operation requires a significant amount of time and resources and a component workforce operating powerful machines to deal with the potentially hazardous and heavy infrastructure. And that's all for today's video. What are your thoughts on this? Let me know in the comments section down below. I hope that you found this video interesting, and if you want to see more videos like this, please consider subscribing to my channel. See you in the following video with some more of the latest updates, and until then, stay tuned.